Practical Investigation, Part 5. Determining a linear equation or a linear mathematical relationship from the graph. From the graph, once the gradient with its uncertainty and the intercept with its uncertainty are determined, we can write a mathematical equation or mathematical relationship that best fits the gathered data. The general linear equation y equal to mx plus c, as you are all familiar, can be written in a more detailed form as below, like this. So instead of writing n for gradient, you write n plus or minus its uncertainty. Instead of writing c for intercept, you write c plus or minus its uncertainty. Y is still y, x is still x. This example here is a graph of A versus B. Instead of y versus x, we have A versus B. Then we have these error bars. You'll notice only the A error bars are drawn. There's no B error bars. That's because the uncertainties in B are not big enough for plotting. And then you'll notice the dotted line. That's a line of best fit. And then this top blue line is the error line of maximum gradient, and the other blue line is the error line of minimum gradient. Gradient calculations from the graph. I presume you all know how to calculate gradient from a line graph. If this is a line graph, then to calculate gradient, you need to draw a step like this, and it is the rise divided by the run. So for the best fit gradient, or gradient of the best fit line, it is the rise divided by the run, and it gives us that. Also, the gradient of the error line is rise over run, and it gives us that. Then the uncertainty of the gradient is simply the difference between the two gradients, and it's plus or minus 0.17 changed to 1 sig-fig, plus or minus 0.2. Intercept calculations from the graph. In this case, you just read off the graph the intercept for the best fit line, which is that, and the intercept of the error line, which is that. And the uncertainty is simply the difference between the two intercepts, and it comes out to be plus or minus 1, exactly 1 sig-fig. Final mathematical equation or relationship. Putting all the numbers or all the values together, we have A equal to the gradient with its uncertainty times B plus the intercepts with its uncertainty. And A is the dependent variable, B is the independent variable. The first one is always dependent, the second one is always independent, because the first one depends on the second one. And this is the equation that best fits the data.